Okay guys, so today we're going to be chatting about the Nanao MS8-29 arcade monitor. This particular one came out of a Daytona, USA. You can see from the pictures on the screen here that the burn-in on this tube, which is the standard Toshiba tube, I'll put the model number on the screen, but the burn-in is absolutely terrible. Just flicking through the pictures here quickly, you can see this is a high-hour tube. It's covered in dust. The dust is just so thick all around the anode cup, all around the high voltage. It's just caked in dust. This particular monitor was sold in a Daytona, USA to me as non-working, and I've pulled it out of the cabinet and taken it over to my unit to blow off all the dust, brush off all the dust, and just use the compressor with the air to get it off before I bring it inside to properly clean it. So you can see here on the video, we're just having a quick look over the whole monitor. And again, you can just see how ridiculous this dust is. Obviously the burn-in and the thick dust just talks to how high hour this tube must be. In a second here, you'll see we'll move on to just brushing it off and blowing it off. So let's have a look at that. So here we are, just giving it a quick brush. Just trying to get all of the loose stuff on the top before I hit it with the compressed air. So you can see here, it already looks a lot cleaner, and we'll just jump in the video here. So this is just a quick overview showing that the tube is a lot less dusty now. It looks a lot more presentable, all things considered. Obviously it's still covered in dust and it's still pretty dirty, but at least the loose stuff is now removed, which will allow me to take it over to where I'm going to strip this down and work on the chassis. Just before we get into that, I just want to show the windings on the deflection coil. As I said, this monitor was sort of sold to me as not working, so I wanted to make sure that there was no issues with the deflection coil. So I'm just checking the readings here with a multimeter in ohm or resistance mode, and you've got two windings. You've got horizontal and vertical, and the horizontal is the red and the blue, and the vertical is the yellow and the brown in this case. Sometimes the colours vary slightly. So we can see here on the horizontal windings we've got 0.8 ohms, and then as we've moved forward we've got the vertical windings, which is 6.6 ohms, and we'll compare that to the sort of readings that I've seen online in a moment, but we will compare that. Some people will say to just check the resistance of the windings, and as long as you've got a resistance, it's not an open circuit, it's not blown open, that's good enough. But it's actually good practice to check the inductance of the windings as well. So here we are checking the inductance of the windings. We're back to the horizontal windings, and we can see we've got 0.386 microhenries. So this is it's a bit new to me, but we measure inductance in microhenries, and this is just a meter I've recently picked up to do this job. Here we are looking at the vertical windings, and we can see we're slightly higher on the scale here, and we've got 18.08 microhenries. As promised, here are the values that we just discussed on screen. So you can see, as said previously, this is an MS8-29FSG. This is a particular chassis. The tube is the pretty standardized across the MS8, MS9 range, the Toshiba tube. And we can see that the yoke readings we got previously are now in this little table here. On the other side of this screen is the arcade wiki. I'm not going to try arcade Botaku. I can't pronounce things to save my life. And we can see here we've got the little legend, which is just saying horizontal inductance, vertical inductance, horizontal resistance, vertical resistance. And if we actually just go down to the nearest thing, actually if we go down to all of them, you can see that if we were looking at an MS9 perhaps, actually let's start off with the MS8. So the nearest thing is this MS8 FAN 29-inch. Obviously it's a variation of the chassis, but we can see for the horizontal inductance we got 0.355 and I got 0.386, so it's in the ballpark. The vertical inductance was 18.7, I got 18.09, so again in the ballpark. Horizontal resistance was 1 ohm, 0.8, okay. Vertical 7.9, 6.6, so it's kind of in the ballpark. So in my mind that tells me that the yoke is good. Just for contrast, if we look at the MS9, which was the successor, we can see it's similar. You've got 3.15 there, 18, 18, the horizontal 0.7 and the vertical 9.3. But the actual interesting thing is, and I'll see if I can update the Wikipedia page on the MS8 to explain this. But I found that somebody said if you do connect, so an MS9 yoke has different connectors, so you'd have to cut the connectors and splice them to work on an MS8 chassis, but it will work, but it's either something like the picture is too tall or too short, or not wide enough or too wide. It's marginally out, but you can make like a pigtail adapter to adapt it and make it work, because the readings are very close, but obviously just different enough that it's not quite as 100% one-for-one compatible. So just an interesting point. Okay, so I've now moved over to where I'm working on the chassis and the tube and trying to restore this particular arcade monitor. And just on screen here is my current setup. I've moved all of my equipment to this place. Multiple times in the video you're going to hear me refer to this place as a different place or another place, because I don't want to derail this video too much. But you can see from the picture where I am with this equipment is quite dated. The reason for that is I'm actually at my late grandmother's house. The reason that I've been away from YouTube for almost a year now is because actually she passed away last year, and I had to care for her and go through her, be there for her in her last moments and look after her estate in the days after. So I don't want to derail this video too much. I will be listing a separate video talking all about that, and all I can say is that obviously it has been a very emotional time for me. But let's move forward with the video. Before we get into the restoration and the repair work on the chassis, what I've actually done is I've connected up my CRT tube tester to the Toshiba tube that was on this MS8, and I've checked the emissions on the guns. If you want more information on how this tube tester works and what I'm doing here, I have got a separate video on the tester itself, so I'll link that. But simplistically, what you can see here is you've got the gun selector and the three guns, the red, green, blue, and I'm just running through showing pictures of what the emissions are on the three guns on this tube. And you can see that basically all of them are sitting within the red, bad, or just above bad emissions, which means that should this tube actually work, or should this chassis work, the picture would be extremely dim. It would be very washed out, colours would be very muted, and obviously it wouldn't be any good to anybody. So whilst it could potentially create a picture just about, I don't think it would be very useful to see it like this. So what I've gone ahead and done is I've actually used the tube tester to do a clean and balance. It has a clean and balance function, which is a less intensive cleaning and burning cycle of the guns. I forget the technical terminology for it, but basically it's just a big electric shock and it burns off any dirt, but you are wearing away the parts. So this is a one-trick pony. It's one-way trip. You could potentially completely destroy the tube doing this, or you could burn off enough crud to allow for higher emissions and potentially a slightly better picture for a period of time. whatever that is, maybe a year, a couple of years. So this tube is kind of dead either way, and I want to use it for testing. So I've taken the hit and attempted this. And as we move forward into the next pictures, you can see that actually the emissions became good. It became somewhat reasonable after doing this process. So I'm kind of considering this tube. Well, the good news is, of course, is that the tube had no shorts, had no G1 shorts, it had no whatever the other setting is for shorts on it, I forget now. And that doing the rejuvenation, doing the clean and balance caused the emissions to go up a little bit. And hopefully if I can get this chassis working, we'll be able to have a pretty decent picture on it, including swing burning. Okay guys, so we're partway through the video, I suppose, already. But this is the first time I've ever recorded my voice this year, 2023. A lot has changed, a lot has happened since my last uploaded video. I'm going to do a separate video about that. I just wanted to start this video off, and I've just gone to put my phone on the tripod mount and it's just snapped, so hence the shaky cam, so apologies for that, but here we go. So this is the MS8-29, oh, it's got a weird FPG or something, I don't know, I'll put it on the screen. And I've noticed that it's quite well documented in terms of caps and stuff. So I thought I would give this one a go over the MS9s that I've got, arcade monitor wise. So we'll just have a quick look around the chassis. We've got two fuses. There's one glass fuse there, one glass fuse there. Obviously we've got a lot of different caps. We've got a lot of different resistors. Some of them are more larger ceramics, some of them are more traditional. And then we've got the neck board there. This monitor came in a Daytona USA, which was sold to me when I got there. I was told it was working, and then when I got there he told me, oh, it's working but it's playing blind, the monitor doesn't work. So great, thanks for that. So I've never seen this monitor work. I don't know if it was the monitor, if it was the chassis, if it was something else, but this thing was filthy. I blew it out the other day, which you'll see a bit earlier in this video. And today I'm just coming over to try and remove all the caps, do an inventory, do an ESR reading, and check some values of resistors and see how we get on. I'm just having a quick look here because this is the first time I've ever looked at this. I don't think I'm seeing any bulging caps. Yeah, I don't think I'm seeing any bulging caps, but obviously they do look very dirty. We could have some cracked joints. I don't know what yeah. So I wanted to get this in, you know, completely new. I've not touched this, so I'm going to pull the screws out so I can get to the underside of it, get it out of the plastic shell casing, and we'll go from there. So let me do that and come back to you. So that's the chassis removed from the casing now, and there was the 4 perimeter screws, but there are also 2 in the middle there, so just watch out for that, and obviously be very careful with the plastic clips. You can see this one is slightly fatigued now, but generally it seems okay. I'm sure if they did snap, the screws will hold it more than amply. So that is the base plate sort of removed. So we've now got the chassis out, and we can have our first look at the underside of it. And let's have a look. What are we thinking? Considering this is quite a high hour, it's not got as much burning as I maybe expected, but you can see, for example, this transistor here, the soldering on that looks quite weak, it's quite thin. How are we looking on the flyback? Yeah, potentially not too bad there. Where's some of the big headers and things like that? Some header pins. Yeah, so what I'm going to do is I'm probably going to bring the scope in and have a better look at this under the scope, and we'll see what that looks like. Just before we get into the chassis, I decided that actually having the neck board flopping about the place isn't great. Obviously it looks like this cable will just remove because it's socketed. Have to cut that cable tie and replace that later. And then the cables on the other side again, this one, if I can get my finger there, it's socketed. Then the other one is the G2 voltage, it seems to say there, something about G2. That's soldered, so I'll have to desolder that one and cut those cable ties. And then you've got the, excuse my ignorance on this because I'm not so up with all the technical terms, but you've got the, I think it's the focus wire there, and you need to declip that. And we can see that this was a high hour tube, and the soot on that neck socket is just insane. But we'll gently prise that open. We'll do that one last. So off camera, I'm just going to snip that cable tie, remove that one, snip, snip. We'll pull the back card off, and then we'll have a quick look at that before we desolder. Looking at the back of this neck board, we can see there's an awful amount of soot and what have you around the edge, which again just speaks to how high hour it is. The wire we want to desolder is going to be this one here, so I will desolder that one, and then we will remove the focus wire and hopefully be able to get this off. So I will use the, let me just move that out of the way. Just like in previous videos, I'm going to be using my desoldering station here. I have moved locations, but I'll explain that a bit later on why. Just for completeness, I'm going to quickly show this. So I've flipped up that cap. You can't see that. Flipped it up, it actuates backwards once you push out the tabs. And then the wire here is soldered in, and I've just used the soldering iron to add a bit more solder, straighten it out, and then I'm going to just heat it up and pull it out. And then the wire actually sits in like a little groove within the cap. So I'm just going to do that now. Actually, I've changed my mind. Now we've got the neck board desoldered, we'll just have a quick look at this. So this is looking at one of the legs of the main large resistors, R325, and we can see there's some pitting on it, but it generally looks okay. We'll obviously clean that up, reflow that. The other side again generally looks okay there. Let me just see if I can add a bit more focus. There we go. Bit of pitting maybe, but looks generally fine. Let's have a look at some of the smaller solder joints. Again, I think it's just dirty, it just needs a lot of cleaning. Just turn the board around slightly. Again, that looks generally okay. And just a lot of dirt on this edge of the board. Looks quite dull there, and whether that's just because of how dirty it is. Let me see if I can just get a little brush to just remove some dirt there. And that there is the well, I can't think what the technical term is, but it's the transistor for the B, for the blue. You can see the middle pin looks a bit crusty, so we would clean and reflow that. Legs on the main resistor on the other side. Again, I think that's just dirt. Yeah. Now obviously this didn't put out any colour, so we just check. So I don't think it would be just like a transistor. Where's my finger? There it is. More interestingly, does that say B as well? Did they both say B? That would be weird. And then where's the third one? The third one is here. Okay, that's somewhat strange. They all say like that B. I thought one would say R for red and G for green and B for blue, but evidently not. So we'll clean and reflow that and test those, make sure they're not shorted. Just have a look at the pins on the neck adapter. Again, they don't look too bad. You would expect to see some cracking, but I'm not seeing cracking on this particular one. Maybe some gentle ringing on that one, but again, it's not bad. But they'll all get reflowed. And go from there. So yeah, generally happy enough with that. Let me just check the connector pins. Yeah, it's not the strongest solder in the world, it's quite thin, but I didn't think there's any cracking on the pins on this header. But they'll all get reflowed. Where's the other header? Over here. Yeah, doesn't look too bad. So generally, somewhat happy with that. Obviously that's the capacitor there. It's quite dirty, but yep, happy with that for now. So this is looking at the underside of the flyback now, and again it's a bit fluxy, but I'm not seeing any cracking on that, which is obviously good. Not sure if I'm going to get over to the other pins. I mean, that one there looks like it's got a little bit of a sort of halo ring to it, but again a bit of a reflow, that will be fine. So I would say that the flyback soldering looks fine. I'm just going to try and turn it around. It's a bit awkward because of how I've got to position this. And we're just looking at the soldering now on one of the main headers. Again, that doesn't look too bad. So I'm not going to try and bore you too much with this. I'm just going to go through this and have a little look and see if I find anything interesting. Earlier when we were looking at this, before I started to get the microscope out, I pointed at an area of heat. And I will put a photograph up of this just so you can see for context exactly where this is. You can see this part of the board is browned because of heat, and I was a bit concerned about potential ringing on this. And yeah, now we've got the scope in. Let's have a look at the soldering on this. I'm just trying to bring in a screwdriver. Here we go. Yeah, these three legs on this part here, they clearly don't look great at all. And actually, when you look at the other side of the board, you can see this part is almost touching this transformer here. So I wonder if there's some sort of like heat issue between the two, and it's caused all of that to sort of burn up. So I think what I'll probably do is actually take that part out, clean the pads, bring it back in, and you can actually even see, look, how that leg is longer than the other two. It's almost like it's leaning over towards this, which is what the case is. So I'll try and straighten that out a little bit so it's not so close, and resolder all of that. And you can even see the pads behind it here. Those three there look a little bit suspect as well. So all of this area will get a reflow. Okay, on the screen now is the full list of capacitors that were removed from the board. They're not in any particular order, it's just in the order that I removed them, I believe, from memory. And we can see I've done this process before in some of my other videos. We've got the locations there, we've got the real values, the voltages, diameter, height, leg spacing of the capacitor itself. And then we get into what I've actually read the values of my real capacitors at. So we've got an ESR rating in ohms, we've got V-loss, and then we've got the actual capacitance value that they are now. The brand, model, tolerances, these should all be M's. I've just missed M off of that. And then we've got a is it in spec column. Now, by default, this is saying, okay, 20% is the actual value in microfarads within 20% of the stated value. And instantly a few of them have failed. I don't know of an exact example, but one that's well out of tolerance. So probably, well, actually that's ironic, that one's true. But you can see like 421 is quite away from 470, but evidently not 20% enough. But anyway, so that would be an instant fail. But then what I've also done is some of these are a manual fail, and it's based on the fact of the V-loss is high. I was reading online and people were saying generally if there's a voltage loss of more than 3.5%, then the capacitor is bad. So you can see we've got some 5%, 4%. So I mean that one's 13%. So I think that one's pretty dead. And then it's the same principle with the ESR rating there. If you get a really high one, then it's not really great. Depending, you have to look at an ESR table depending on the capacitors, but sort of anything over maybe an ohm or a couple of ohms is generally bad. And you look at this, quite what's going on with this capacitor, I don't know. 150 ohms ESR, mind-boggling. You know, this one here, 45 ohms, just crazy. So I think there was quite a lot of capacitors that were well past it here. But this table would allow you to go in, order your own capacitors and work out what you need to do. And actually it matches, there's a Wikipedia page with a table on it, and it perfectly matches that. So that guy has done a brilliant job tabling it all up, and I'll put a link in the description to that, but obviously you've got my table here as well if you so wish. The only thing to report is, and I had a cold when I was doing this, but this capacitor absolutely stank. It clearly blown his guts, and everybody says about the fish smell with capacitors, but this was the first time I've really smelt it. So yeah, there were quite a few dodgy caps here. Okay, so we're day 2 on the MS8 chassis now. Did about 4 or 5 hours yesterday on this one. So I've been going through it. I've desoldered all the capacitors now. They are all sat over there. They're all tabled up, and I'll have edited that in by now. I have ordered a new tripod stand thing for the phone. That's going to come Friday, I think. I've been going through the whole chassis, trying to work out where the issue is. I've obviously taken off the 2 daughter boards. I've removed the connectors for medium res and standard res. I've removed the solder but not the connectors and re-soldered these. I've checked the HOT in circuit, I've checked the HOT out of circuit. That's been resoldered and cleaned. I had removed the coil because it reads as 0 ohms and 0.1 ohms. So I assumed it had failed, but I'm just chatting with somebody on the forum and it's potentially that's not the case, which is annoying because I thought, well, if that's a direct short, maybe that's failed. I'm going to try and remove this component here, this transistor here, just so I can redo the firmware paste and again test that one. Now you will remember at the start I did say that this area looks to have had a lot of heat and it looks a bit crusty. What I didn't do is I didn't actually touch the component from the back whilst looking at it. And I don't know if this is going to show. I'm just going to try and find my way to it. Yeah, there we go. Can you see that? Can you see that the legs are wiggling? So, yep, that part isn't even soldered in anymore. So, I guess the heat has finally caused those joints to crack. So, I'm hoping maybe that was the issue for why this wouldn't show a picture. So the next step will be to desolder all of the components in this area, clean up the pads, clean up the heat, resolder those in. I've also taken the flyback out just to, again, clean the pads, clean up any excess flux, and be able to clean the other side of the board, which I'll show a bit later. But overall it's cleaning up quite well. I've got some areas down here I'm going to want to remove and clean, and again up here I've got some areas that I just want to clean so that there's less flux residue and it just looks all nice and tidy. And then there was a big lump of glue there and a big lump of glue there, and I've been able to successfully remove that one when I did the HOT to clean that up. So I'll maybe do the same over there as well, because glue can go conductive over time, so I just want to avoid that. And yeah, I'll come back to you once I've removed this part, I think. So the component is now removed, and looking at it under the scope you can clearly see the pads are just gone. This part has obviously got so hot that the pads have just disintegrated. So what we're going to have to do is we're going to have to use a fiberglass pen and just scrape up this trace a little bit here, and bridge maybe with a leg, component leg, between this pad and here. So I might scrape the whole thing off and then just put like a capacitor leg or something. This one here, again, we'll just scrape this back a little bit and just put a little leg in there. And this one will get scraped back and probably put a full leg in there. Here, I'm going to actually remove these two legs from the circuit. This resistor does test good. I've tested it, it's bang on the money, but we can see that joint there looks a bit shifty. So I will pull this out and I'm going to actually scrape the solder mask off here and just bridge that. So that's one big solder joint, and this one, of course, I'll remove that, clean that up a little bit, and probably bring this back to here a little bit, and then solder that one as well. And then all of these I have touched with clean solder, but I'm actually going to remove it all and probably try and clean it as best as I can, and then resolder all of this area. This resistor is the, where's my screwdriver? It's the resistor 542, that one there. And this part, I'm trying to work out what that is. I can't, 532 maybe? But I'll look at it on the other side of the board and see if I can work that out. For whatever reason, I didn't record audio at the time for the voiceover here, so I'm just doing this retrospectively. But here we can see what I was just talking about, where I'm just running over the components, well, where the components once were now, just looking at these traces. So just using the fiberglass pen to remove the solder mask, and you can actually see that that pad as well, when I finally removed the resistor, the pad was completely gone. So what I'm going to do here is just run through all of these traces and pads and just scratch them down with the fiberglass pen, which is just abrasive enough to do it and also not cause too much damage. You can take your time with it. So I'll go on a time lapse quickly and we'll just whiz through this. I'm just going to quickly add in some photos of this area, and these are photos just with the iPhone, because the scope doesn't always capture sort of how clean something looks or how much better it looks in reality. So we can see here that the solder mask is all removed now, and obviously the pads look terrible, but the traces have held up, it's all nice and clean now, and it's ready to start resoldering in and doing some repair work. So you can see here that things are still quite fluxy, so I'm just cleaning it. But generally the pads at the top there look a lot nicer now, and you can see the repair work that I've done. Some of the more critical of you might think that the solder isn't really touching the pads, or the pins of the transistor. And after I fully cleaned this up and had a closer look at it, I wasn't happy that there was that much solder joining the transistor back to the circuit, even though it was ringing out with continuity on the multimeter. So I didn't catch it on camera, but I did go back in and add a little bit more solder to this, and I think I've got a photo to show you in a second. So even here I wasn't actually 100% with the center pin when I took this photo, and I did go back in and add more solder to that, and now I am happy with all 3 pins on this one. Okay, so at this part of the video I'm just going to do a bit of a montage of pictures I took in the cleaning. You can see here with this one, just look at the before picture here, the sheer amount of dust that's on all the capacitors, the big gloopy glue holding the capacitors together, the big filter caps from when it was new. As we move on to the side picture here, you can see the board should be bright green, and it's kind of like a black, dark grey colour in areas where the dust is just so caked on, it's unbelievable. As we come round to this side, you can see where the adjustment potentiometers are, and again, just a thick layer of dust. I'm going to keep repeating that because well, what else do you say on that one? As we look at the neck board, this is quite interesting. I didn't notice when I was doing it, but looking at the pictures, I do wonder if that capacitor has maybe split on the top, because the sort of triangular, you know what I'm trying to say, how the top is closed, it looks like it's maybe vented, so that's quite interesting. Looking at the underside of the neck board, we can see lots of flux residue from factory. I didn't really see any bad joints on this, but again it just looks very dirty and very tired, so I've gone through, removed a lot of the solder, cleaned up the flux residue and resoldered the neck board. Again, looking at the side here of the adjustment potentiometers, and you can see that I've started to remove the capacitors now, and you can see that I've started to just wipe a little bit around the pots, and you can just see the color difference already, and we're not even anywhere close to final cleaning. This is an overhead shot now, and you can see the filter caps are removed, and just look at the difference around the filter caps. You can just see the thick, and it is black in that area, the thick black dust that was just caked around those capacitors, and you can just imagine that that probably held a lot of heat and would eventually cause a lot more wear on the capacitors because it's retaining heat. This side here, this was just a picture to show that weirdly there's a capacitor that actually goes over that resistor directly above it, and it's not listed. So if you didn't make a mental note of it, you might miss that. So it's quite important to know that there is a capacitor also in the holes for a resistor. And again, you can see the color difference on the board there just from a quick pass with a sort of wet wipe. Here we can see I've taken the flyback out, and I'm glad I took that decision in the end, because just look at the color difference from the soot from all the high voltage that was just drawing into that area. And taking off the side metal shrouding, removing the flyback, allowed me to really get in and clean this area, and also gave me better access to the capacitors that are sort of dotted around the flyback. Here's a close-up, and you can just see how much soot was caked on that heatsink area as well. And this was great because it just allowed me to really get in there and clean that up. And that's an after shot of the cleansing, and you can see that the board is green again. So this is now looking at the side where the daughter boards were, which have now been removed in the capacitors, and you can clearly see the areas I've started to clean compared to the areas I haven't. But you can also see there was a big blob of that glue again behind the daughter board, holding it steady in the manufacturing process. And I did actually go in and loosen that up with some alcohol and eventually remove that, I believe. Also, that big resistor there, the 5.6K, I did test that and that tested fine. This is looking a bit further up the board now, where your high-low resolution headers are, and you can see, again, very caked on with dust. This is looking again at that upper corner now. There was another daughter board there, which has been removed, and we can see, again, more glue, more dust. This is now after a pass of cleaning, and we can see that some of the larger film capacitors are looking quite shiny where I've cleaned them. We can see that the top of the transformers is now looking quite nice where they've had a clean as well, and it's starting to look how we want it to look. This is now looking at the fuse area, and this is pretty close to my final pass of cleaning, and you can see it's really starting to shape up nicely now. This is now looking at the underside of the board, and this is what I've talked about through this video, and this is the pin headers for the high-low resolution change. And you can see again a lot of flux residue, a lot of dirt, and we want to get all that off. We want to get that all cleaned, and we want those soldered in pins to look really shiny, really nice level of solder. You can also see what I mentioned as well about the big glob of glue around the HOT, which I've actually had to use a knife to cut through the glue and just cut it down and get it thin enough to use alcohol to remove and scrub that off. This is now showing the pin headers removed, and you can see I've gently cleaned the area, and the pads are all looking quite good on this, quite fluxy on one of the transistors there, but that gets cleaned up later on. This is just moving forward with the reflow work. Here we are looking at the top of the board in that sort of area now, and you can see with those headers removed I've been able to really get in there and clean that area and move forward to reassembly. This is just having a closer look now at where the filter caps were, and you can see there is quite a lot of heat damage at the back there where that part that it desoldered itself, and it's amazing that it generated so much heat. It's scorched both sides of the boards there, but you can see it's looking quite clean now. This is a overhead shot, just at I think this is at the point where all the capacitors are removed now, and I felt that the board was pretty clean, so I just took a moment to take a picture of that. This is now looking at the underside, and you can see clearly the solder, wow, it's looking all nice and shiny, nice and clean. And I've reflowed all of the transistor joints there, I've reflowed the fuse headers, I've reflowed the pin header, and it's just all looking so much cleaner and so much nicer, and hopefully ready for years of use to come. This is looking at the other side of the board where one of the larger ceramic resistors are, and you can see again we've got lots of flux residue that needs to be tidied up. This is an overhead shot of the underside of the board. You can see the flybacks back in now, that's all resoldered in, and I think this is probably part way through re-adding some of the capacitors, and it's generally starting to look a lot nicer. So these are the final two pictures now, and this is just showing the underside of the board completely, everything soldered in, everything done, and I'm really happy. I actually know somewhere I've missed a dry joint, or there must be a failing ceramic capacitor or something, because from a cold start when you turn it on, you do get a slight ringing of something, and then eventually that goes away, and apparently that can be the sign of a cold solder joint that's been missed, and its ceramic capacitors will ring. So I need to go back and have a little look at that, but generally speaking, I'm really pleased with the work. This is a final overhead shot of the board all reassembled with all the new capacitors on it, and you can see just how much cleaner it is compared to what we started with now. I'm really pleased with what I've done here. Okay guys, well here goes nothing. I've not recorded a lot of stuff, but I have rebuilt the chassis now, cleaned everything up, fitted all the new capacitors. Obviously we found that component that looked to have desoldered itself, but other than that, at a glance, everything else that I've looked at looks fine. I've had to build a custom loom or a little adapter just to use the test pattern generator and fit a power supply to it, because obviously it's not in a cabinet. So I've done that. I have confirmed, as far as I can tell, that my step-down transformer is not an isolation transformer. So let's hope that the MS8 doesn't need an isolation transformer. Yeah, I'm going to give it a go. I'm going to turn the test pattern generator on. So that's it on, everything's plugged in. The step-down transformer isn't plugged in. I'm going to plug that into the wall now. Hopefully we don't get a bang when I hit the switch. We will find out, I suppose. Oh man, okay, let's go for it. That doesn't sound great. Okay, well, stuff happens, but let's turn that off. This is the day after now, and I had to sleep on this, have a little think about it, because something wasn't right. I'd spent, I don't know, like 10 hours doing the capacitors straight. You know, I was thinking of solder flux, I was tired, I was determined to get it to power up. I'd achieved that goal, and it was time to just take a step back and have a think about it. And of course, speak to experts, people that knew more about this than I did. The footage you're watching is, like I say, the day after, and it's just me messing about with it and trying to see if I could work out what was going on. And you can see that there's these weird artifacting lines that keep coming and going. You can also see that the picture is offset. It's not centralized in any way. It's hard left. And it's just an odd issue. It's a really, really odd issue. And this is the first arcade monitor I've rebuilt, so it's something that's new to me. And I did have to refer to the experts on UK VAC and got hold of Gunblade, and I said, look, can you look at this and tell me what am I missing? And it was at that point that he said, you do realise it needs negative sync, right? And I was like, no. Where does it say that online? You know, where's the big note that says, by the way, these monitors use negative sync? You just sort of assume it would use the positive sync, right? Because that's the header on the test pattern generator. And he's like, no, you need negative sync. So there were two problems at play here. I'll just bring up a picture of the test pattern generator a second. So with the test pattern generator up, you can see here that you've got a sort of main header, which is the RGB, the ground, vertical, horizontal sync. But you've also got a secondary header just on the side there, which is a separate ground and negative vertical and negative horizontal sync. These monitors actually use composite sync, and this test pattern generator puts the composite sync out on the H, on the horizontal pin, which is the white coloured cable in this case. And basically all I had to, like I say, there's two issues here. I had to take the sync pin and put it over to the negative sync pins, and I had to change the battery. In rushing to get this done, I'd actually forgot to bring a 9-volt battery over with me. So I ended up taking a 9-volt battery out of one of my old multimeters, and the battery was low. So I put a brand spanking new Duracell in the test pattern generator, changed it to negative sync, switched it back on. What do you know? It works first time. So this is the first picture I've got, and this is what it looked like in the immediate aftermath of changing the battery and the sync. And I was just like, whoa, okay. We've got all three colors, we've got a nice centralized image, bit of pin cushioning. Obviously the elephant in the room is the massive color bleed in the lower right hand corner due to a magnetic effect of something, probably the step down transformer that was over in that area. And essentially I haven't at this stage rigged up a degaussing switch to my pigtail, so I was unable to degauss the monitor outside of the cabinet. But the day after I did go and get a switch and sort that out, so that was pretty cool. But you can just see here a couple of different pictures, just chucking up a checkerboard and chucking up the the crosshatch pattern. And you can see that it's a nice full image, pretty bright considering how low the emissions were on the tube. And generally, yeah, pretty happy. When we go over to the fully white image, and I know the pictures aren't the best, and I do apologize for that, but on the fully white image, you can see just how much burn-in is in this screen. You can see that you can clearly make out link system at the top, and racers are wanted, and Sega, and insert credits, and what 0 of whatever credits it is. So this tube really isn't usable, I don't think, because that's just going to be way too distracting. But it's a test tube, it would be excellent. And obviously I'm really pleased to even see it work. So the next steps were trying to tweak it a little bit, get the degaussing switch wired up, and then go from there. This is just a quick still to show after degaussing just how vibrant the colours are. I mean, obviously I've not calibrated this, but just wow. Considering how tired this monitor was, just considering how low the emissions were, I'm really, really pleased to see 3 vibrant colours appearing on this monitor. Getting into this video now, this is just me racing through, showing the white screen after degaussing, and the Sega logo is very clear in that bottom right hand corner now. You can see as we go through the test patterns, that's just me adjusting the red, I think, there, just to see if I can make it look a little less, well, a little less red and a little more grey. And we'll just go through all the different patterns. It's probably important to note this is in medium res mode, and the checkerboard is quite a bit more dense in this mode. And there is quite a bit of waviness in the image, and I don't know, maybe I can bring that out in the calibration a bit later, but we'll see on that. Here we've got the checkerboard, and you can see it's quite nice. We've got the color bars, and then the equivalent pattern. Solid red, solid green, solid blue, and the white again. Okay guys, so I just want to round up this video now. Obviously I appreciate it's not been the most perfect of videos. Sadly some of my equipment broke in the process. This is my first video in nearly a year. So obviously there were some bits I couldn't film. But I think generally speaking it gives you an insight into what the MS8-29 monitors are like. Gives you an insight into what sort of problems you might see on the chassis, what capacitors to order. A good point actually is to mention I did build a cap kit project on Mouser, and I will leave a link to that in the description as well, so that people can order the exact caps I ordered if you so wish. They were about £25 or something like that. But also on the screen here I've got the MS8-29 page. This page will probably change because I'm now registered with the forum, and I fully intend to update this page and add my findings, add information that I found useful that isn't on this page. But without this page I wouldn't have been able to do what I've done. So I just want to say a massive shout out to these guys and the effort that was taken. And the big thing for me, I think, yeah, it's this link. This is just fantastic. As a cap guide, with the diagrams, with the full the table there of all the values, just the level of detail and the effort that's gone into this. It's really spurred me on to go in, because this doesn't exist for the MS9 monitor. So I'm going to take the time and give back to the community, and I'm going to do the same thing for the MS9 monitor, just to say a sort of thank you really, because I think this has been really helpful. And you can spot things, like I said, that little capacitor that sits on the resistor, it's there. There is actually a bipolar cap somewhere. Where is it? That one there. So, if you didn't know the direction of the caps and all of that, then this is absolutely really essential. And I have checked it, and it's bang on correct against my MS8-29FSG as well. And like I say, all the values were correct as well. I didn't go with all of the replacements that were recommended, because a lot of them were Panasonic and I prefer Nichicon caps personally. But overall, absolutely outstanding effort and massive help. So yeah, I'll leave a link to this page in the description as well, because I think it's very important. And I would say keep an eye on these Wikipedia pages for these monitors, because I'm going to try and put some effort into it as well to help. So hopefully you found the video interesting. There's a few things I didn't cover. I didn't cover how to set the B+, because I haven't actually checked that on mine yet, which is very important. You can either do it from one of the fuse legs, or there is a test point, but I can't find good information on which test point is for what test. So once I find that information, I will be putting it on this page. And yeah, I think it's a good spot to leave it. I will do a follow-up video when I'm going to strip the cage down, get it zinc plated. I'm going to clean everything up, change the Toshiba tubes around to put a better tube on this particular monitor because of the burn-in, and I'll do a follow-up video for that. So thank you for watching. Please like, subscribe, contribute to the video, leave a message if you found it useful, and I'll see you again next time.